Hello everybody, welcome back to the Bison Workshop. I'm Bob, and I think we're about done with this top. I got my new aluminum plate. I've got to do a little trimming yet on it, but right now I've got it to where it'll work. So I'm going to show you what we got. But before we do, let's have a congratulations in order for old Mr. Donald Trump. He mopped up the floor with her. Now she can go get her a job sniffing farts out of the bus seats at Greyhound bus station. Anyway, let's look at this thing. So I got my pulley, got my aluminum plate, and I milled it out right here, a slot, so that I can get into the set screw for this part right here of the shaft. Because this shaft goes down on another shaft, and then it's got a set screw on the bottom of it. Well, I had to put that in there so I can access it. All right, then I got two set screws in this one, and they're tight. And I had to put a nut on these screws. These are the original screws that held down the other plate that used to be on it. So I put a nut on the top of it and tightened them down. So now this plate is nice and tight. You ain't gonna have no flex. Basically, I just milled out the slots for each motor mount. Then on the bottom of this pulley, on the bottom side of it, I milled out a round pocket and glued a magnet in there with some RTV gasket maker. And then I put this on there. This is the speed sensor for this DRO. So I'm not going to need that speed sensor anymore. So looks like I'm going to be using that for the lathe. So this is going to turn into a magnet plate. That's what it's going to turn into. So this one here is about a 37 millimeter pulley, and this one is a 50 millimeter pulley. And I think it's a good ratio. I mean, I won't know until I really get into depth with cutting. But I want to try to trim this out a little bit right here, just kind of make a fancy design, and then make this round right here, and then just directly go to this corner over here, like that, at an angle. I don't know yet. I'm going to leave this the way it is. I'm just going to chamfer these corners and file them real nice. I was in a hurry to get it back together. So now let's test it out. Now this is the original motor, and that's all that's original, except for I wanted to keep this option where I can change this. So I'll have my high and low. Low has a little more torque to it. So this is probably going to change because these pulleys are different. They're not the same size as what was on it. It used to have a 37 tooth here and a 20 tooth here, and they were actually meshed together. Now it's got a 50 millimeter and a 37 millimeter pulley on the motor. So now let's fire up the airplane. Now this one here is the RPMs, and right now it's reading 0. So now let's turn it on. Nice and quiet. Right there. we got 6,500. And that's on low. Now I've turned the potentiometer down, and now it took some time for it to go down. All right, so now let's put it in high. I gotta turn the, there we go. All right, so now let's see what we can get on high. I want to see what my lowest can be. All right, at around 100, it's ready to stop. See that wobble? That makes me mad. I tried to get Keith Rutger to make that pulley for me, but he won't answer me on Facebook, so oh well. All right, so let's see what we got for high. $6,000. So that is the finished motor upgrade for the mill. I did use this mill with the wooden one. It's laying right there in the floor. I did mill all this stuff out, and I think it turned out pretty nice. And I'm really glad I thought of doing this. And what I did, this size shaft right here is the pocket that I made for that size, and it's a groove in there like this, a slot. So I can adjust that this here from left or front to back. So if I ever change the pulley, I have my options open to change the location of that. So even the sensor is adjustable. The motor is adjustable. This is adjustable, because before, when it had this plate on it, and forgive my mess, I'm telling you, when I start a project, it gets messy. When this was on there, it went down all the way and you couldn't see in here. So the motor was here with the gear going up against this gear. Well, it's got slots in it to adjust it. Well, those slots mean nothing anymore. Once you mount this down, you can't get to those to adjust it. You have to adjust it before you put it on. That's almost impossible to do. So, other than drilling a hole all the way up through that thing and putting a big old Long Allen wrench up in there to adjust that motor, it ain't happening. And that's why that damn motor chewed up that pulley. Because I couldn't get it adjusted exactly the way they had it, because I had taken everything apart. So now it's bisonized. And everything's working pretty decent. My control box is working pretty good. The DRO is working really nice. And I really like this plate that I put on the front of it. Now, I don't know if I'm going to paint this thing black or not. It's cleaning up pretty nice, so I might just leave it the way it is, because it don't look bad with that aluminum and white and some black. I want to utilize these bolts here for something someday, you know. I could put my shield back on it if I ever wanted to, which ain't never going to happen. But I can use these for other things. I do plan to use this one for this. I'm going to put one of those little wire holders right there. And I may even put a wire holder here on both of these to bring that up just like that right there. and then out the back. So right now I've just got it draped back in there so it don't get tangled up in the coil or the spindle. So I got a lot of wire policing here to do. This is just temporary wiring solution right now, but I gotta redo these wires. So we gotta put it in a way to where this will move up and down. So it's gonna have to be pinned here somewhere and made so that it can go up and down. So now we have the mill up and running again. All the parts are made for it. And I'm happy with it. It looks a whole lot better. Now, yeah, I could probably take and cut a slot in here to relieve for the belt, and I could probably set that right down on there and just put some little L brackets here to screw it to, and that might work. I don't know yet, but if I do, this is going to get painted black, I hope. I don't know how I'm going to. I need to get me some more letters like that. Take that off of there and mask these off. There ain't no way I'm masking all them letters off. But I like to have that covered right there. I do like that part. But it looks better like that. It looks more like a mill than a toy. So there's the mill. Motor upgrade, pretty much done. I'm going to call this the last video for this. If you got any questions, and if you want any dimensions of what I've got here, I think I've pretty much covered everything. This is a 10 by 8 plate, and all I did was took this and turned it upside down and put it on the plate and drawed all the holes where they was going to go, and didn't draw this hole, just this one, and I drawed all the motor screw holes, and I drawed this one. I cut it out to this size right here, which is a 2.5 inch hole. So basically it just goes on the outside of the bearing, not the inside of the bearing. So then the other one was drilled, the one for the pulley shaft. That one is 1 3/8. So then I just drew a straight line, or drew a straight line across here in the middle, in the center. And then I drew a center line going from here straight across for the center of the motor. So the center of the shaft on this is lined up with the center of the shaft on this one. And this center of the shaft is lined up with this center of the shaft. So it's just basically a L shape. So I don't put these videos up to show people step by step how to do something. I show you my idea. And I give you some measurements and stuff like that, but my mind just doesn't work like that, guys. And as you can see, my mind is cluttered, because if my bench is cluttered, I'm cluttered. My mind is cluttered. So it's too much going on up here. So I used a 16-inch belt. I tried a 15. It was too short. It brought this first adjuster bolt, the motor mount bolt, too close to the side of this. So I went to a 16-inch belt. I also got the 17-inch belt just in case I needed it. But even if I don't need it, I don't mind having stuff like this in stock because I can make pulleys for other stuff and make other things. So I don't mind having extras. So that's my mill DC motor upgrade. I hope you guys learned something out of this and got some ideas of your own, or maybe one of my ideas triggered an idea you might have. That's what it's all about, guys. Looking out for each other. That light comes on. I wonder if it blinks when it's turning. Yep. Turn that airplane off. I gotta quieten that thing down. That's just too damn noisy. It's the 24 volt power supply that I took out of a 3D printer. And it's got one god awful loud fan in it. The other fan that's in here ain't that loud. It's a computer fan. But the power supply itself is located right here. It's got a really loud fan in it. I don't know if I can take that fan out of there, take the cover off of it so that it can get air circulating through the system, or if it needs direct fan. I don't know yet. So I'm going to see if I can't find a quieter fan first, or take that fan out and put one of my 12 volt fans in it, which I know is sufficient. I just won't be running the power off of the power supply. I'll be running running it off of my 12 volt power supply. So, but the 24 volt goes to the Z-axis motor, which is this. This used to be a one of them little tiny battery operated scooters for kids. I took the motor out of it and used it for this. And I even used the pulley. Of course, I already have a video of that. Anyway, don't forget to like, share, comment, subscribe. Definitely don't forget to celebrate our win. You guys have a good one. Later.